now we'll look at classifications, because we all see a lot of stuff about classifications. This is we use the Whyte system. It's Frederick Whyte was an engineer, mechanical engineer in the New York Central. He said back around the turn of the century, he says, we gotta get something here because this is complicated. We got to figure out some way. And so he came up with the numbering system that we use for steam locomotives. The lead truck is here, and you have to have, like passenger engines have to have 4 wheels up here because you have to pull that engine around. That's a lot of mass, a lot of inertia, and you have to pull that engine around the curve. And if they didn't have it, they learned very quickly, you got to have, especially if the track is rough, you got to have a lead truck. Now the axle loading on these is about half or less of the drivers, but it's enough to pull the engine. Then you have the drivers that are driven by the pistons. That's the middle number. And then in back is the trailing truck. And that's does two things. One is it supports the firebox. And also if the engine has to back up, it allows the engine to negotiate curves going back. Now in the UK, they were using, they go by axles. So as a Pacific is a 231. And then they came up with a UIC code. I think that comes from the continent of Europe. And the powered, it's actually a good system. So your idler axles are just numbers. And then your powered axles, no matter what's powering them, in this case, it's a Pacific locomotive. So you have 2 axles, idler axles, and you have C means 3 powered axles, and then 1 is 1 idler axle. And then guess what? We use that for diesels because a BB is 2 axles powered, and then in front and 2 axles in back. A passenger engine in the olden days was an A1A, A1A. That means there was a motor, and then the center axle didn't have a motor, and then the back axle had a motor. And then of course, most of them now are CCs, which means three motors in front, 3 motors in back. Interestingly, General Electric is now making freight locomotives that are A1A. And they have this exotic system to unload the center axle when they start the train. And then once they get going, they only need 4 motors. So it cuts down on maintenance. So the Burlington Northern's got some of those. Not, they don't use those on coal and heavy trains, but for manifest, they work pretty well. So these are all the Whyte steam locomotives. The Northumbrian, that's obviously from the UK, was an 022. And then we had, they figured out right away that switch engines don't go very fast. They only go around the yard. You don't need a lead axle or a trailing axle. And so you can put all the weight on the drivers. That means you have more tractive effort, because the more weight you have on the drivers, the more tractive effort you have. Usually it's about, back in those days, it was about 1/4 of the weight. If you have 50,000 pounds on an axle on a driver, then you have 12,000 pounds of tractive effort. And then 6-wheeled switchers, 8-wheeled switchers, and then you got into some huge ones in special cases. So here's a 6060, no axle in front.
Narrow gauge.
Huh?
That's narrow gauge.
No, it's regular. This is the engine that ended up.
I'm looking at the counterweights on the wheels, drivers.
Yeah, they're big because it's a small driver.
Okay.
This is the engine that ended up at Rolock,
Okay.
Western Steam Threshing, and it's an 060, but it has almost as much tractive effort as that Pacific, because it's all the weights on the drivers, and it could move a lot of cars around the yard.
That's another reason for the end of steam, is those counterweights, they beat the shit out of the track.
Exactly.
Because no matter how you counterweight it, you're gonna have bang, bang, bang on the track all the time. Don't get that with diesels.
That's exactly right. It's a continuous force. That's another good point, Craig. I thought I'd throw Thomas in. He's an 060 tank.
Yes, a tank.
They actually have full-size Thomases. That's interesting. So, and then here's a New Haven. It looks like this was a 282 that made a heavy duty switch engine by taking off the lead truck and the trailing truck. So that's,
Oh, okay.
but that's a big switch engine.
That's a big.
And then here's the ultimate switch engine. Now this is the Union Railroad in Pittsburgh.
Pittsburgh,
They are owned by United States Steel, or were owned by United States Steel. And they hauled huge trains between the mines, or between the various plants in Pittsburgh. And so they had an 010-2. Now that is the ultimate huge locomotive. So we keep going with all these tank locomotives. We'll talk about one of those, and then some of the early ones, the Planet, the Jenny, some of those. So here's a typical tank locomotive. This is an 040. And again, like we've talked about, the steam locomotive has to have a lot of water. And so that's why the tank is wrapped around the boiler, because they need room for it. Now that little bunker back here is enough coal probably for a shift, just shifting around. But they have this whole tank full of water, because they'll use that up probably in half a shift, depending how much they're shunting around. So that's a tank locomotive. Now here's the 220, and these obviously around 1820, and a 222. So, but it was Stevenson who came up with the idea that you got to have a firebox in back, you lay the boiler down, you got the chimney up here, you have a stack to blow the exhaust out and suck it through the boiler, put the pistons, so he was kind of the one who laid out the original steam locomotive. Okay, then the biggest tank that was common around 1850 was the 1840s, the Mason Bogie. We'll look at one of those. And then there were Atlantics and Baltics. It's 464. The Baltic, the Hiawatha, if you remember, the Hiawatha went from Chicago to St. Paul and Minneapolis. And initially, when they streamlined the trains in the 30s, they bought Atlantic steam locomotives. The Zephyrs and the were buying diesels, but Milwaukee said, no, we're going to use a steam locomotive. And so they bought Atlantic, the 442 steam locomotive, and they were running about 7 cars, and they'd run up to 100 miles an hour. They made it in less than 400 minutes. Well, then the train kept getting more popular, and so they had to get increased to 12 or 13 cars. They had to get a 464, but they did not call that a Hudson. They called it a Baltic, because of course they couldn't be Hudson, so. But here's the Mason Bogie. It's a tank locomotive, even though the tank is back here, because it's all one frame. This is all one frame. Then we started getting into some of the bigger ones, 242s at Columbia, Forney, the Mogul and Prairie, 260, 262, in the last part of the 1900s, 1800s, and the early part of the 1900s, very common. The Great Northern and the Northern Pacific here locally had hundreds of them. And then we have the Adriatic, which is a 264. That was used in Eastern Europe quite a bit, but not in North America. And so Lionel made a lot. That was their most common locomotive. I was wondering, where did they get that? And then the consolidation. Well, here's a consolidation. That's actually a model, but it's a two wheels in front, 8 drivers, and then no wheels in back. And that was a big, very common late in the 1800s, early in the 1900s. Here's the Lionel Adriatic type. So that's the only way you'll find one in North America. They sold a lot of those because they're 027 and anyway. Let's see. Oops, sorry, going the wrong way.
Wrong way, right?
No, here there we go. Mikado was probably the most common prototype engine in North America. 282, and apparently the first ones were bought by Japan early in the century, and the emperor at that time was Mikado, and so that's how the name stuck. And then, of course, in World War II, they tried to change the name, but railroads, you don't change much, so it still was a Mikado. In narrow gauge, most of the Rio Grande locomotives on the narrow gauge were 282s. And then I talked about Lima and their superpower. That was the Berkshire. locomotive, which they first came out with, where they put a big firebox. We'll look at a picture of one. And it's named after the Berkshire Mountains in Massachusetts because they ran from Boston to Albany. They were the first ones who bought it. And then of course there's Decapod, and then I think we gave some to Russia in World War I, and there were Russian Decapods. The Santa Fe had 210-2s, and then the Texas and Pacific had the 210-4s. So here's a 282 Mikado. And then here's the 2 K27. That's, they call them mud hens. You can see why, because the counterweights are in the mud. Small drivers, but they were good pullers. So, and then here's the Berkshire. And you can see that the firebox used to be between the wheels, like on the American, but it got big. That's the Lima figured out to make a big firebox, and then superheat it. They have a feed water heater up here. They had everything on it. And so they pulled a train with a Mikado across the line up in Massachusetts, and then they pulled the same train with a Berkshire, and the Berkshire was much faster and used less fuel and hauled more tonnage. So the efficiency was quite a bit increased. So this superpower concept with the big firebox, well designed, really took off. So
anyway.
nominally, generations are considered to be 25 years. So I divided steam up into 6 generations. 1825 is when they really started building them. The Baltimore, Ohio was getting going, and railroads in UK and France. 1850, and that's about the time that the American steam locomotive, we'll look at that. I think everybody's familiar with that, the 440. And then from 1850 to 1875, the American was pretty much kind of the standard locomotive. We'll look at some pictures in a minute. And then about 1875, they started adding more axles and making the steam locomotives bigger. And then in 1900, bigger yet. 1925 is when they started Lima engines in Lima, Ohio. If I got that right. It is Lima. It's Lima, Ohio, right? Isn't it?
If you say Lima and Lima, they'll throw you in the river.
What about the company that builds steam locomotives? Is that Lima or Lima?
Lima. It's Lima all the way.
Oh, it's Lima. Okay, well, I'll correct myself then.
Yeah. Said from a guy who grew up in Ohio. Yeah.
Okay, all right. So Lima steam locomotives started the superpower, and we'll look at some of those where they really figured out how to make steam run a lot better and more efficiently, and that was from 25 to 50. And there were railroads, we'll look at some pictures at the end that tried to keep steam going, but it just, the economics as we've seen. And then from 50 till now is basically the restoration.
To Germany had more horses than they had vehicles.
Wow.
They had over 1 million horses to move stuff, including the fodder. Now, what about railroads? Did they have diesels? Not very many.
Yeah.
Germany had coal. They did not have a lot of oil. It was synthetic. Now we can talk a whole bunch about all the different battles and all that and how they tried to get fuel. That was another problem with the FT-109 or whatever it was, the great fighter that they had in the war over Britain. It ran synthetic fuel. And guess what? That fuel did not have the energy of the high-grade petrol.
Oh, interesting.
So it reminds us not about Germany, but about different times and places in our world where different energy sources and different types of energy were effective. That's like in recent times, it's common to have engines driving alternators in order to have power in some of these areas of the world. They don't have big plants like we have in this country in all areas. And they consume a lot of water.
And diesels are very, yeah, that's true. But they've really made diesels very, very efficient. So in remote areas, yeah, the diesel plant.